Let's go through LeetCode 1340 jump gain 5 and giving an array of integer ARR and an integer D. In one step, you can jump from index I to this kind of I plus X, and it has this condition. That means we can jump to the right as long as we are not go out of the bound. And we'll see X, the maximum is D. And also that means we can jump to maximum will be I plus D. And as long as it's not going out of the bound. So on the right, it will be minimal A minus 1, right? And I plus D. And on the left, they can jump to the left, that is I. And for this condition, that is X somewhere equal to D, right? So that means we can jump to I minus D, right? And also we need to make sure it's not going to go out of the bound, so it will be max I minus D and 0. And this one will also be included. So from I, he can jump to this kind of range. That is the condition where a user can jump. And it also says that in addition, you can only jump from index I to index J if ARI is greater than ARJ. That means we can only jump, for example, I to a lower position. And it has another condition, and ARI greater than ARK for all the index K between I and J. That means if I have an array J will be greater than ARI, right? And outside this J, if I still have a shorter one, for example, K, this we cannot jump to. That means we can only jump to those kind of position which will be shorter and within this kind of range. If there is a taller one, and it will be act as a wall, will stop the jump outside of the taller wall. So the same thing on the right side. If we have J is greater than I, we cannot jump to the other side, jump across the wall. So it is just 3 conditions. I minus D, I minus I plus D, and a bound 0 to A minus 1, and also 2 walls, right? Walls left and the walls right. So there are 3 conditions we can jump. So what we are going to do is that we start from every index, trying to jump to the left and iterate for this kind of bound. And also, if there is a wall, we just break. And then we jump to the right. Also, we go through the bounds that is I plus D and a minimal I plus D and A minus 1. If we meet a wall on the right, we stop. So we have a DFS trying to do this kind of simulate these conditions. And then we have an index I from 0 to index N minus 1. And for this DFS, we return those kind of steps. The DFS functions that the jump steps, and we compare get the maximal counts. So let's write code for this. Int equals array dot minus. We'll have max count because there. So int I 0 and next equals x dot next and DFS I. We should have array I D return next. Index int D so I have results. So 0. And from this index, I cos index -1, right? And I greater equal to max dot max 0 and index -d I minus man. If array I was greater equal than array index, we just break. Then result was max dot max DFS array I D. So this is to the left. That means if we get a wall which is higher taller than my current index, then this will not will just break this kind of iterations. We cannot jump anymore. Also to the right, a smaller equal to max dot min idx plus d in the n minus 1 I plus plus. So we'll also have if array I greater equal to array index, then we just break. Then result equals max dot max DFS array I D. And for the initial, let's count. For example, this one 12, right? This 1 to this is 1 2 3 4. So you see that you can jump from 10 to this index 10 to index 8, then to index 6, then to index 7. That means the initial part, the 10, will also count 1 times. So we need to have a result. So this will be the DFS to do this. Okay, actually, for this question, we'll find that mm, we are iterate from left to right, and we'll see from the 6, we can jump to 4, right? And the next time we try to go to the index 4. Actually, this 4 is already been calculated. So there, the same thing is that, for example, we stand at 14, right? We can jump to here, and the 6 is already being calculated. And if we jump here, the 4 is also jump calculated. So there are a lot of duplicate calculations. So we can add a memo for this DFS to avoid the duplicate calculations. We have int memo equals new int. And for this DFS, we add an memo inside here. Let's say if memo next equal to 0, just return memo next. And for here, we should add a memo. Here we should add memo. And we will sort this result to be memo index equal to result. Okay, doing like this way, we will find we just iterate the array, and for each array, we just go to the left d steps into a maximum that will be d steps, and to the right will be maximum will be d steps. You know, because so for the if we already have those kind of counts, we just return the counts. So for this kind of solution, is that we will if there is some kind of index, we already calculate those kind of steps. Then we are not going to the we are not calculate the next jumps. We just return, right? So so for every index, we'll calculate once to get the result. And also we'll iterate the whole array. For the whole array, if we iterate, that is an ON time complexity, and for each index, we are at most have to the left there is d steps, and to the right d steps. So the time complexity will be OND, and the space complexity is that we have a memo here that is ON space complexity.